مريم. مريم.
ايوه
إيه الأخبار؟
الحمد لله.
إيه أحسن النهاردة؟
الحمد لله.
تمام الحمد لله. يلا بدنا نبدأ.
يلا بينا.
يلا بينا. بسم الله الرحمن الرحيم. بسم الله. Chapter 2 is called quantitative chemistry. Quantitative chemistry. Okay, so chapter 2, which is called quantitative chemistry, has two lessons. Lesson number 1, which is called mole and chemical equation. Mole and chemical equation. Lesson 2, called calculating chemical formula. Calculating chemical formula. So, what are the names of these two lessons?
Mole and chemical equations and calculating chemical formula.
Chemical formula, okay. Let's begin lesson 1. Lesson 1, mole and chemical equation. So, what's meant by chemical equation? First, chemical equation, as you studied in middle 3, when, as example, when oxygen gas reacts with magnesium, magnesium oxide is formed. Such as reaction are described by balanced equation known as chemical equation. This is called chemical equation. Okay, chemical equation consists of 3 parts. Number 1, the part before arrow. This part before arrow, this part before arrow, which is called what? Which is called reactant. Called reactant. This is part called reactant before arrow. And the another part after arrow called product. After arrow called product. And what is on the arrow is called conditions of reaction. Condition of reaction. As example, in this reaction needs heat. Okay, so as any chemical reaction, if one of the reactants was oxygen, so you must put triangle as heat, as this reaction will be produced inside the air, okay, in air. So as example, 2Hg2Mg, S. S means what, Mariam? Letter S means what?
S?
Yes. S means solid. S means solid. Plus O2. O2. Okay. G.
Okay.
G represents as gas to produce 2MgO. 2MgO as solid. Okay. So when you write any chemical equation, you must put these symbols below the chemical formula. S means solid, G means gas, L means liquid, AQ means aqueous solution. Aqueous solution as present in water. Present in water. Okay? So this is the beginning and describe of chemical equation. What about these numbers? 2, this one,
the amount,
and this 2. What about this number?
the amount of the thing that I'm putting?
Number of moles. This is called the number of moles as 2 mg So it means that 2 moles of magnesium react with 1 mole of oxygen gas to produce 2 moles of magnesium oxide. Okay, so the first number is called number of moles. So in this chemical reaction, 2 moles of magnesium atom react with 1 mole of oxygen molecule to produce 2 moles of magnesium oxide. Okay? Any problem till now?
Okay. No.
So what about this number? What about this number below the letter? As O2. What's meant by 2? Can you answer me,
Number
Mariam?
of
What?
number of atoms.
Yes, number of atoms in oxygen as O2, it means that 2 oxygen atoms. But what's the difference between these 2 and these 2?
The first 2 means that we have 2 moles of magnesium, and the second one is we have 2 atoms of oxygen.
Yes, but 2 Mg means also that 2 magnesium atoms. But this magnesium has solid state. Solid state. So we can't write 2 below Mg. So we can't write Mg2 only. It's false. It's wrong. Wrong. Mg2 only, it's wrong. But we must write 2 Mg. And 2 Mg means that there are 2 magnesium atoms plus O2. O2 means that this is 1 mole of oxygen, 1 mole of oxygen gas, but oxygen as a form of gas, so it must contain 2 atoms. So it must be O2. O2 means that this oxygen molecule consists of 2 oxygen atoms to produce 2 MgO.
Okay.
Okay, to produce 2 MgO. Okay, and we must make balance. Mariam, we must make balance for this equation. What is the balance? 2 Mg plus O2. So what is the number of magnesium atom that react in this reaction?
2.
2. Good. And what is the number of oxygen atoms that react also in this reaction?
2.
2. So you must get rid of 2 magnesium atoms and also 2 oxygen atoms. So the product will be 2 MgO, as these 2 multiplying Mg and also multiplying O. It means that 2 Mg and 2 O. So the number, okay, the number of product, number of produced atoms equal to number of reactant atoms. Okay, as 2 Mg react with 2 oxygen atoms to produce magnesium oxide compound that consists of 2 magnesium atoms and 2 oxygen atoms, and this called mass. This is called the conservation law of mass. Conservation law of mass. Okay, this is the explaining this equation, and this explanation for about any chemical reaction that must be balanced, and we must know how can we make a balance for this chemical reaction or any one, that the number of reactant atoms must be equal to number of produced atoms to be balanced. Okay, and take care from the atoms that react in chemical reaction. If these atoms are solids or gases. If these atoms are solid, So we must write the number in front of letter. But if these atoms were gases, so we must write the number of atoms below the letter. Okay?
Okay.
Any problem till now?
No.
Okay. So try to read first paragraph, Mariam.
Chemical equation properties.
Yes, chemical equation.
Okay. It's composed of the chemical formulas and symbols of the reactants and the products. Both sides of the equation, the reactants and the products, are separated by an arrow describing the condition.
Mariam, I think that your voice has a problem. Your mic has a problem.
Maybe, I don't know.
I think that it makes a noisy.
The internet is not good.
Okay, okay. So try to repeat again. Number one, chemical equation properties.
It's composed of the chemical formula and symbols of the reactants and products.
Yes.
Both sides of the equation, the reactants and products, are separated by an arrow describing the condition and direction of the reaction. It
Yes.
describes the quantity of reactants and the products, the number of molecules. It describes the state of reactants and the product solids are denoted by S, liquids L, gases G, and aqueous solutions AQ as shown in the previous equation.
In the previous equation, so it describes the state of reactants and product. Solids are denoted by S, liquid L, gas G, and aqueous solution AQ, as shown in the previous equation. Okay, so chemical equation that we said before should be balanced, which means that the number of molecules of reactant should equal the number of molecules of product. And this is known as law of mass conservation. Law of mass conservation. Okay, try to repeat it again, Mariam.
Chemical equations should be balanced, which means that the number of molecules of reactants should be equal to the number of molecules of the product. This is known as the law of mass conservation.
Law of mass conservation. Okay, so chemical equation, the representation of chemical reaction using chemical symbols, formula of reactants and product, and the description conditions of reaction is the meaning of chemical equation. Okay, so what's meant by chemical equation again?
The representation of chemical reactions using chemical symbols, formulas of reactants and products, and the description of conditions of reaction.
Okay, what's meant by molecule and difference between molecule and atom? Molecule is the smallest particle in a chemical element or compound that has the chemical properties of that element or compound and exists alone. So this molecule. So molecules of substance can keep its properties. Okay, can keep its properties and can be existed individually. Can be existed individually. Okay, this is the meaning of molecule. So what's meant by molecule, Mariam?
It's the smallest particle in a chemical element or compound that has the chemical properties of that element or compound and exists alone.
Just alone, okay. What's meant by atom? Atom, the smallest building unit of matter. Smallest building unit of matter, which takes part in chemical reaction. Smallest building unit of matter which takes part in chemical reaction. So what's meant by atom?
It's the smallest building unit of matter which takes part in chemical reaction.
Chemical reaction, okay. How to balance chemical equation? How to balance chemical equation, okay? Number one, to balance a chemical equation, we should make sure that the right side of the equation has the same atoms of the left side of it. Okay, it's the main idea. It's the main idea. To balance a chemical equation, we should make sure that the right side of the equation has the same atoms of the left side of it. Example, Al plus O2 to produce Al2O3, and also NaNO3 triangle to produce NaNO2 plus O2. Try to think about how can you make balance for the first equation, Mariam?
Yes.
Okay, try to make it. Al plus O2 producing Al2O3. So how can we make this example? How can we make this equation balanced?
Exchange of valency.
Yes. So please, Mariam. It's Al O2 this is as Al plus O2 producing Al2O3. How can we make balance for this equation? Okay, this equation. How can we make balance of this equation? First, what about the aluminum atoms produced? Two. So we must put 2 before aluminum, right?
Yes.
To be what? To be the number of atoms that join in chemical reaction must equal 2. So try to put 2 to aluminum, okay? And this is O2, okay? But if the product was O3, how can we make O2 equal to O3? How? What? I can't hear.
I'm still thinking about it.
Yes. How can we make O2 equal to O3?
Putting there two, putting there three, and then beside the Al2 or O3, I'll put two.
Mariam, please try to close the TV beside you. Okay. O2, how can O2? Okay. How can O2 be O3? I think this is 2 and this is 3. Okay.
Yes.
How can we make a balance between them?
Put a 3 beside the 2 and 2 in the other product.
What?
A 3 beside the O2, like it will be 3O2, And in the product, it will be 2 Al2 or O3. And
Excellent.
then in the Al, we put
Excellent, Marin. So we must put here 3. To be 3 times 2 equals 6. So this is 3. We must put 2 because 2 times 3 equals 6. But there is a problem. 2 times 2 aluminum equal what?
4.
4. So this is not 2. So this will be what?
4.
4. Excellent. 4 because it's a solid. So what are the product equation will be? 4Al plus 3O2 arrow by heat produce 2Al2O3. And this is the final equation, Mariam. This is what? This is final equation. Yes, as this is 4 aluminum and this is 4. 2 times 2. This is 6 oxygen and this 2 times 3 equals 6. So this equation is a balanced equation. Do you understand?
Yes.
Any problem?
No.
Okay. Let's return back again. What is the, how can we make balance for the second equation? 2 NaNO3 equal NaNO2 plus O2. How? By the same way. By the same way, okay? As Na NO3 arrow by heat produce NaNO2 plus O2. How can we make a balance? First, we must account number of atoms. This one sodium, and this is also one sodium.
1.
This is a nitrogen, and this is nitrogen. Okay. What is the number of oxygen atoms here?
3.
But what is the number of oxygen atoms there?
4.
4. Try to make this 3 equal to this 4. How?
It will be 4 NaNO3 in the reactant, and in the product it will be 3
So we were
Na.
right. So do you mean that we were right 4 here?
Yes.
Okay, 4. So 4 sodium, it must be 4. So we will put 4 here.
Yes. Magic.
Yes or not? You said that we must put 4 in front of sodium, in front of this compound. Okay, right?
Yes. Yes.
So we will put, what is the number
Yes.
that we are going to put it before NaNO2 to be balanced? Do you mean 4 also? Try to make 4.
No.
Okay, try. Try to make 4. 4Na, 4Na, 4n, 4n. But 4 times 3 equal what?
12.
So we have 12 oxygen. Okay, but 4 times 2 equal what?
Yes.
What?
8.
4 times 2 equal what? 8. 8 plus 2 equal what?
10.
10. So this is 12, but this is a 10 oxygen. So it's false. So we mustn't write 4. It's a correct answer. Try to think again.
Okay.
Try to put 2. Okay, Mariam?
Okay.
Okay, 2. Instead of 4, we will write 2. So 2 sodium, 2 nitrogen, and 2 times 3 equal what?
6.
6, okay. This is 2. Try to write here 2. 2 times Na, 2 Na. So it's excellent. 2 times N equal 2. So excellent. 2 times 2 equal what?
4.
4. Plus 2 equal what?
6.
6. So this true or false?
True.
What?
True.
True. Excellent. So this is true. So we must put 2 here. So what about the final equation? Will be what? Okay. Try to say, Mariam. What about the final equation?
2Na NO3.
2Na NO3 arrow by heating equal what?
Arrow
Produce what?
heat equals 2Na
2Na
2N
NO2 plus
O2.
O2. So this is the final equation, balanced equation as 2Na 2Na 2N 2N 2 times 3 6 oxygen, 2 times 4 2 times 2 equal 4 plus 2 6 oxygen. So this is a balanced chemical equation. Do you understand?
Yes.
Any problem?
Yes.
Any problem, Mariuma?
No.
It's okay. Let's begin. So this is equation. This is the answer of first one. Try to read, please.
Okay, we find that there are 3 oxygen atoms on the right side of the equation, while there are only 2 on the left side of it. To balance the number of oxygen atoms on both sides, we should increase the number of oxygen atoms on both of them to 6. 6 is the least common multiple of 2 and 3.
Yes.
There are 4 aluminum atoms on the right side of the equation, while there is a single atom on the left side. To balance the number of aluminum atoms on both sides, we increase the number of atoms in the left side to 4 aluminum atoms.
Excellent. So finally, will be what? Will be 4 Al plus 3 O2 equal to or produce 2 Al2 O3. And according to the second one, try to read.
The number of oxygen atoms on the right side of the equation is 3, while that on the right side of the equation is 4. To balance the number of oxygen atoms, we increase the number of oxygen atoms on both sides to 6.
To 6. So this is must be 2, and this must be 2 to be balanced. Okay. Any problem till now?
No.
Okay. So first, second, this is another part.
I don't have the mole.
What?
I don't have the mole here. I have a chemical equation and the chemical compounds like ionic compounds and covalent and
Yeah. All this after that molecular mass and molecular mole. So this is introduction for mole. this introduction for mole. Okay, how can we calculate the mole? Okay. So we studied before that every element has its own mass number, right?
Okay.
What's meant by mass number? What's meant by mass number?
I can't hear anything.
What is meant by mass number?
نعم أنا مش سامعة حاجة.
What is meant by mass number? Mariam.
Yes. The number of protons and neutrons in the nucleus of element atoms.
Okay. Can you hear me well now?
Yes.
Okay. Thus, if we want to calculate the atomic mass of an element, we only calculate the mass of its nucleus. Why? Why, Mariam?
Because the mass of the electrons is too small if compared to those of protons and neutrons.
And neutrons, okay. So atomic mass are measured by unit called atomic unit or AMU. Atomic mass are measured by a unit that's called AMU. AMU, atomic mass unit. Okay, atomic mass unit. And atomic unit or atomic mass unit has a fixed number. Okay, so one mole of any substance has a fixed number which equals 1.66 times 10 power negative 24 grams, or 1.66 times 10 power negative 27 but kilogram. Okay, if the mass number of oxygen is 12. Okay, if the mass number of oxygen is 12, so its atomic mass equals what? 12 AMU. Okay, so we can measure atomic mass of oxygen but by AMU. So if the mass number of oxygen is 12, so its atomic mass equals what? 12 AMU, and so on. Do you understand?
Yes.
So what's meant by mole? Mole is the measuring unit of quantity of matter. Mole is the measuring unit of the quantity of matter. Okay, how to calculate the mole? How can we calculate the mole? Okay. Try to read this paragraph, Mariam.
If the atomic mass of oxygen is 16 AMU, so 1 mole of oxygen equals 16 grams. If the atomic mass of nitrogen is 14 AMU, so 1 mole of nitrogen equals 14 grams.
So what's meant by mole? We can conclude that what's meant by mole? What's your calculation? What's your conclusion? What's your conclusion? So the meaning of mole is what?
The atomic mass?
Yes, but expressed in grams. Expressed in grams. Excellent, Mariam. Excellent. Okay. So mole is the atomic mass of substance, but expressed in grams, not AMU. Okay. Right?
Okay.
So AMU meaning that unit of atomic mass. But if you wrote grams, so it's a mole, because mole is the atomic mass of substance, but expressed in grams. Do you understand?
Yes.
So
Yes.
if atomic mass of carbon is 12 AMU, so 1 mole of carbon equals 12 grams. If we want to know the mass of a molecule, okay, pay attention here. Okay, if you want to know the mass of a molecule of compound, not element, molecule of compound, so we add the masses
We use the
of
molecular mass.
we add the masses of the atoms forming it, and in this session, okay, which is called molecular mass. Called what?
Molecular mass.
So what's meant by molecular mass?
The sum of the masses of the atoms forming molecules of a compound.
Yes, sum of masses that represent sum of atomic masses. Sum of atomic masses of the atoms forming this molecule of any compound. Okay? So again, what's meant by molecular mass?
The sum of masses of atoms forming molecules of a compound.
Excellent. So this example, try to show this example. Try to read it, please.
The molecular mass of carbon dioxide molecule CO2 is the sum of masses of 2 oxygen atoms and 1 carbon atom. If the
Yes.
atomic mass of oxygen equals 16 U and that of carbon atom equals 12 AMU, therefore the molecular mass of CO2 molecule 12 plus 16 plus 16 equals 44 AMU. Mole of CO2 equals 44 grams.
Excellent. So what's your observation here? What's your observation?
That carbon dioxide is forming from the sum of masses of oxygen and 1 carbon, and the mole is equal the atomic mass in grams.
Yeah, so we can calculate the molecular mass of CO2 gas as any example. That C means what? Okay, we must know atomic mass of each atom. Okay.
Okay.
Okay. Okay. Pay attention, Mariam.
Okay. Yes.
If we have, how can we get the molecular mass of CO2 gas? CO2. You must know that. You must know that atomic mass of carbon equal 12 and atomic mass of oxygen equal what? Equal 16. So try to solve it. So CO2 equal what? C. What is the number of carbon atoms here?
1.
1 times. What is the atomic mass of carbon?
The atomic mass of carbon 12.
So 1 times 12. 1 times 12 plus. This is 12.
2 times 16.
This is 12. Plus, what is the number of atoms in oxygen?
2.
2 times. What is the atomic mass
16.
of oxygen?
16.
So 16. Okay, so you must know that 1 times 12 from carbon plus 2
Will be 44.
times 16 according to oxygen gas. So it will produce what? 12 plus 32 equals what? 44 grams. So it's called molecular mass of carbon dioxide gas. It's called what?
Yes.
Molecular
mass of carbon dioxide gas.
Molecular mass of CO2.
Carbon dioxide.
CO2. It's a molecular mass of CO2. Do you understand, Mariam? Do you understand?
Yes.
Any problem?
Yes.
Okay, Mariam, try to answer this example. Okay. What about the molecular mass of NaNO3 equal what? Okay, and take in your consideration that sodium Na equal 23, N equal 14, and O equal 16. By calculator, try to calculate the molecular mass of sodium nitrate. Go, Mariam.
Yes. It will be 85.
Excellent. Equal 85 what?
85 grams.
Yes, equal
Grams.
85. So Na 23 plus nitrogen 14 plus O3 3 times 16 equal finally 85 grams. Okay, any problem?
No.
So it's 1 mole, or what's the number of mole?
85 moles.
No, it's 1 mole.
Yes, 1 mole. Yes.
So 1 mole of carbon dioxide gas equal 44, right?
Yes.
So
yes.
half mole of carbon dioxide equal what?
Mole.
Half mole.
Equals 22.
22, excellent.
22
and 2 moles of carbon dioxide gas equal what?
88 grams.
88 grams, excellent, and so on. So you must take care from this duplication, okay? If he needs half mole, 2 moles, 0.4 mole, 0.1 mole, okay? Do you understand these types?
Yes.
Okay.
Yes.
Let's return to our booklet. This is 44. Mole and mass matter. Try to read.
We calculated before the mole of carbon dioxide equals 44 grams. So when we use 44 grams of carbon, it means that we use 1 mole of it.
1 mole. How to know the number of moles in math is very important. Number of moles. How can we get number of moles? It's very, very, very important rule that we are going to use this rule in next problems. All next problems, first you must get number of moles. So it's a very important rule. Okay, Mariam?
3.
Number of moles equal what? Number of moles equal mass of matter divided by mass of 1 mole. Okay, mass of matter, divided by molar mass. Mass of matter divided by molar mass. Okay, so it's a very important rule that we are going to write here. That is this as number of moles equals what?
Yes.
Equals mass of substance divided by molar mass.
Okay.
Okay, Mariam, it's a very important rule.
Okay.
Okay, so the mass of substance or mass of matter equal a number of moles equal mass of substance divided by molar mass. This example, the number of carbon dioxide mole in 440 grams of it equals 440. The mass of matter divided by 44, so the mass of 1 mole equal 10 moles. Okay, what's the number of moles? Number of moles equal mass of substance. Equal what? Mass of substance. Mass of substance equal what?
440.
Equal mass of substance equal 440 gram divided by molar mass. Molar mass of carbon dioxide equal 44, right? Right?
Yes.
So number of moles equal
Yes.
10. Equal 10, as we can calculate it. 440 divided by 44 equal 10 moles, as the number of moles
Yes.
equal mass of substance divided by molar mass. And if the mass of substance was 440 and molar mass of carbon dioxide gas means 1 mole, molar mass carbon dioxide gas means 1 mole equal what? Equal 440 divided by 44 equal 10 moles. Do you understand?
Yes.
Any problem?
No.
Okay. Every substance has different molar mass, right? Due to the difference of the molecular structure and atomic mass of this element. Right or wrong? This
Yes.
statement?
Right.
Right, okay. As the structure of carbon dioxide gas differ from the structure of sodium hydroxide, differ than structure of water, differ than structure of sulfuric acid, as each compound has different atoms that forming it, and these atoms differ than the atoms of another molecules, right?
Right.
So every substance has different molar mass due to the difference of the molecular structure and atomic mass of the element. Example, the mole of diatomic molecule or diatomic element, non-metal, are calculated by different way, as the mole oxygen gas in form of molecules equal O2, 16 plus 16 equals 32 grams, right?
Right.
Because this molecule, and we said that the molecule of oxygen gas equal what? The molecules of oxygen gas equal what?
16.
Equal 32. Yes?
Yes, equal 32.
Equal 32 because
Yes.
its molecule as O2, O plus O, 16 plus 16 equals 32. While the mole of oxygen gas is a form of atom, it will be 16 gram as one atom
Okay.
only equals 16 gram. Okay?
Okay.
Okay. There are elements whose molar masses change by change of their physical state. Okay? By what?
Okay.
By physical state.
By the
As,
change
yes, as phosphorus, P phosphorus. Okay, phosphorus molecule in gaseous state consists of 4 phosphorus atoms. So it will be P4, while its molecule in solid state consists of 1 atom only, which equals P. And there is difference between the physical state of phosphorus, either B, gas or solid.
Yes.
Right? Right, Mariam?
Yes.
So try to read it about the phosphorus.
Phosphorus molecule in gaseous state consists of 4 phosphorus atoms, P4, while its molecule in solid state consists of only 1 atom.
So you can treat with phosphorus as solid or gas. If phosphorus was in a gaseous state, so it will be 4 atoms. But if phosphorus was a solid state, so it will consist of 1 atom only. Okay?
Yes.
Also, sulfur molecule in gaseous state is octaatomic, that consists of 8 atoms, while its molecule in solid state consists of 1 atom only. This is sulfur. So the physical state of sulfur differ from gas to solid, as if sulfur was in a gas state, so it will consist of 8 atoms. But if sulfur was in a solid state, so it consists only 1 atom. Do you understand?
Yes.
Okay. So what are the importance of mole? Try to read, please.
It helps us calculate the amount of species required for chemical reaction from 2 Mg plus O2 by heating equal to MgO. From the previous reaction, we deduced the ratio between magnesium and oxygen equal 2 to 1. So the reaction needs 2 magnesium moles and 1 oxygen mole. The number of moles of magnesium should be double that of oxygen.
Yes, so we can understand that 2 moles of magnesium must react with 1 mole of oxygen gas to produce 2 moles of magnesium oxide, right?
Yes.
So try to complete. If 1 magnesium atom must combine with what oxygen atoms to produce what magnesium oxide?
To produce 1 magnesium oxide.
Excellent. Good. So 2 magnesium atom, if 2 magnesium atom react with 1 oxygen, 1 mole of oxygen to produce 2 moles of magnesium oxide. So if 1 mole of magnesium atom make a reaction, so it will react with half oxygen molecule, half mole of oxygen molecule to produce 1 mole of magnesium oxide. So it's a fixed ratio. 2 to 1 produce 2 magnesium oxide. 1 to half produce 1 mole of magnesium oxide. Do you understand? Any problem? Yes. So what's meant by limiting reactant? Limiting reactant. Try to read, please.
The substance that is totally consumed in chemical reaction is complete due to its lack.
Okay. We said that chemical reaction require certain amount of reactants to get the required amount of product. But if the amount of a certain reactant is smaller than the required amount, it's completely consumed. Completely consumed. Such small amount of reactants are known as limiting reactant. Limiting. So we have a limit. We have a limit in this reaction. If this limit was finished, if this limit was finished, so the reaction will stop because there is no extra reactant that can make reaction. Do you understand?
Yes.
So it's called the limiting reactant. As limiting reactant, the substance that is totally consumed when chemical reaction is completed due to its lack. So we must take in your consideration that the limiting reactant will be the least amount or highest amount reactant.
The highest amount.
No, it will be least amount because it will be finished immediately. And when this amount finished, okay, or consumed completely, so the reaction will stop.
Okay, I understand.
Right?
Yes.
So the limiting reactant called what? Limiting reactant, the substance that is totally consumed when chemical reaction is completed due to its lack. So we can understand that the limiting reactant in any chemical reaction will be that have or that has least amount, as when this least amount consumed completely, so the chemical reaction will be stopped. Okay? So try to repeat again what's meant by limiting reactant.
The substance that is totally consumed when chemical reaction is complete due to its lack.
Yes, substance that is totally consumed when chemical reaction is completed due to its lack. Okay. So what about the another part, mole and Avogadro's number? Mole and Avogadro's number. Okay. Scientist Amedeo Avogadro discovered that the number of matter units, either atoms or molecules or ions in all moles of all element is constant. Later that number of moles was calculated to be 6.02 times 10 power 23, and this is called Avogadro's number. And this is a fixed number. That's called Avogadro's number. So what's meant by Avogadro's number? A constant number representing number of atoms or molecules or ions in one mole, and equals to 6.02 times 10 power 23 matter. So what's meant by Avogadro's number, Mariam?
A constant number representing the number of atoms, molecules, or ions in 1 mole is equal to 6.02 times 10, 23 matter units dash mole.
Excellent. So Avogadro's number, constant number. So 1 mole of any substance, okay, 1 mole of any substance has number of atoms or number of molecules or number of ions, which equals a fixed number, which equals to 6.02 times 10 power 23. So 1 mole of water, 44 gram, has 6.02 times 10 power 23 molecules. Do you understand?
Okay.
Example. 1 mole, calculate the number of carbon dioxide gas in 48 grams of carbon. Number of carbon molecules. So we need number of molecules equal what? Equal what?
12
First
number of
we will calculate the number of moles of carbon. Okay, carbon molecule, okay, in 48 grams. 48 grams. So carbon will be diatomic, as mole of carbon will equal 12 plus 12 equal 24 grams. So the mass of carbon will be 24 grams. Number of moles equal what? This is the first rule that we studied, and we said that number of moles equal what?
Mass of matter of over mass 1 mole.
Yes, mass of substance divided by molar mass. Mass of substance divided by molar or molecular mass. So mass of substance equal what?
Mass of substance equal 48.
48 grams. And molar mass of carbon equal what as a diatomic?
24.
So 48 over 24 equal 2 moles. Equal 2 moles. So what is the another rule? The new rule of Avogadro's number equal what? Equal what? Listen to me. Listen to me to the next important triangle. Listen. This is another rule of Avogadro's number. What is the rule of Avogadro's number? Listen to me.
Yes.
Okay. Number of moles, number of moles equal to number of either ion or atom or molecules divided by Avogadro's number 6.02 times 10 power 23. Okay.
Yes.
This is again 6.02. This is a This is a new rule.
Rule.
So we have two rules of number of moles. We have two rules of number of moles according to the reactant. As the first rule will be number of moles equal mass of substance divided by molar mass. Is a very important rule, and it's the first one that we said. While the second rule will be number of moles equal number of either ions or atoms or molecules divided by Avogadro's number, which equals to 6.02 times 10 power 23. Do you understand, Mariam?
Yes.
Any problem till now?
No.
So we have two important rule. Okay? Let's return back to our booklet. This. So this example, calculate the number of carbon dioxide carbon molecules in 48 grams of carbon, while carbon equal 12. So the mole of carbon is the first point that we must calculate mole of substance. So molar mass of carbon will equal to 12 plus 12 equal 24. So the next step that we are going to calculate number of moles, and it's a very important rule, as we said before, and this is a rule that we are going to begin any problem number of moles first, right? So equal to 48 divided by 24 equal 2 moles. So number of molecules equal what? If you have number of moles, okay, try to make a revision for this. If number of moles equal number of ions or atoms or molecules divided by Avogadro's number. So number of molecules equal what? From this triangle, number of molecules equal what?
Equals the number of ion or atom or molecule.
No.
Over Avogadro.
No. I asked about number of molecules equal what from this rule? Number of molecules equal what? If you disappear, number of moles, number of molecules, so it will equal what? Equal to number of moles times Avogadro's number. Right?
Right.
So number of molecules equal number of mole times what? Times Avogadro's number. Times what?
Avogadro's number.
Avogadro's number. Okay? Do you understand? Any problem?
Yes. No.
Okay, so this is the number of molecules equal to times 6.02 times 10 power 23 equal to 12.04 times 10 power 23 atoms or molecules. This will be molecules, not atoms, because this number of molecules. So its unit will be molecules. Okay?
Yes.
Any problem?
Okay. No.
Try to listen to this video, Mariam. Try to listen to this video, please.
Okay.
Why are moles so important for chemists? Well, imagine you're one yourself and you work in a chemical plant. One of your customers has ordered 100 kilograms of copper sulfate crystals. To deliver this, you need to dissolve copper oxide in hot sulfuric acid. This will produce copper sulfate solution from which we can get the blue hydrated copper sulfate crystals that you might be familiar with. Here's the problem though. How do you know what mass of copper oxide to place in your tub of acid? If you use too much, not all of the reactant will dissolve, and you'll have to spend time and effort separating the undissolved solid from the solution. Too little, and you simply won't produce enough product for your customer and fall behind schedule. Either way, you could be in trouble. But with the help of moles and the simple equation, problems like this.
This is the rule of mole. Number of moles equal mass of substance divided by molar mass to calculate number of moles. Okay?
Okay.
Can be easily solved. The first thing to do with any challenge like this is to look at the chemical equation and balance it. Fortunately, that's not difficult here because, as you can see, all we need to do is change the molar ratio of the water from 1 to 4. The molar ratios for all the other species are 1. You now know.
So this is the balanced chemical equation. As 1 mole of carbon, 1 mole of copper oxide reacts with 1 mole of sulfuric acid that reacts with 4 moles of water to produce 1 mole of copper, hydrated copper sulfate. Hydrated copper sulfate means that CuSO4 multiplying 5 molecules of water. Okay?
That every 1 mole of copper oxide reacts to form 1 mole of copper sulfate. 100 kilograms or 100,000 grams of the copper sulfate are required. We need to know how many moles of the product this represents, and here's where the equation comes in. The number of moles needed equals the desired mass, 100,000 grams, divided by the relative molecular mass of the product we want, copper sulfate. Using your periodic table, you can work out that this is 63.5 for the copper atom, plus 32 for the sulfur, 9 times 16 for the oxygens, and 10 times 1 for the hydrogens, altogether making 249.5 grams per mole.
This is the way that we can calculate molar mass. Okay, Mariam? Do you understand?
Yes.
This is the way that by which we can calculate the molecular mass of hydrated copper sulfate, which it's simple is CuSO4 multiplying 5H2O. So Cu will equal 63.5 plus S only equal to 32 plus 9 times 16. Okay, plus 10 times 1 equal finally what? Equal finally 249.5 gram per mole. Okay, do you understand this molecular mass? Okay, Mari.
100,000 divided by 249.5 equals 400.8 moles. So this is the
So by this way we can calculate number of moles of copper that will react with this sample of compound.
the number of moles of copper oxide we need to add to the acid. Now to convert back to mass, and again this is straightforward, we just have to use the equation again. This time we know the number of moles, 400.8, and we can get the molecular mass of copper oxide, 63.5 plus 16 equals 79.5 grams per mole.
It's the molar mass of
To
copper
find the
oxide.
mass, only a simple rearrangement is needed. 400.8 times 79.5 equals 31,860 grams of copper oxide. And there you have it, we've solved the problem. Let's look at another example, a famous one. Here's the Haber process for making ammonia from hydrogen and nitrogen. If you want to know more, we have a video all about this. Imagine one day at the chemical plant we produced 4,000 moles of ammonia.
Okay, Mariam, do you understand, Mariam?
Yes.
Do you understand?
Yes, I
Any problem?
understand.
Any problem till now?
No.
So we are going to complete, inshallah, in next session from this page 36, that we are going to begin with example number 2 before studying ionic reaction. Okay, Mariam? Any problem till now?
No.
Okay, Mariam, thanks for you. And I will record this video, and I will send the link to you inshallah tomorrow. Okay?
inshallah.
Okay, Mari. Goodbye.
Bye.
Goodbye.